Okay, so in this video we will look at solving absolute value equations and inequalities. I don't know about you, but whenever I was coming through school and they were first teaching me about absolute value, my teacher just said, well, if it's absolute value, just make it positive, and never really explained why. But it's as simple as what the definition of absolute value is. And so that's actually where I'm going to start. Absolute value measures the distance a number is from 0 on the number line. So you'll see in my worked out solution key that I have a number line sitting there, and I have 0, and I have +4 and -4. It's measuring distance. Have you ever seen anything in real life where you measure distance using negative values? Probably not, because distance always is a positive measurement, and so it's measuring the distance from 0 on the number line. So think about how many units it is from 0 to +4. Okay, well that would be 4 units. Likewise, then however many units there are from 0 to -4, that would also be just 4 units. So absolute value is positive because it's measuring distance. Okay, just a little aside, a little it helped me when someone finally explained it to me in that way. So anyway, just below that, a fact, it says for any a value greater than 0 in an algebraic expression x, if the absolute value of x is equal to a, then x could be positive a or negative a. It's kind of like what you see up here. If your distance here is +4, well, your x value, think about it, the absolute value of +4 and the absolute value of -4 are both 4. Okay, so if you're trying to solve for the absolute value of x to be a +4, then +4 or -4 could be your solution. Okay, so x could equal, let me get my pen so we can see it here, x could equal +4 or -4. Okay. All right, so with that said, we'll just scoot on down here to example 1, and it just says, solve this absolute value equation. So here you have x equals 1/2, and so you're asking yourself, what can you take the absolute value of and get a positive 1/2? And just like I was just talking about in that blurb up here at the top, I could think about it, the absolute value, my x value could be a positive 1/2, or it could be a negative 1/2, right? Because the absolute value of positive 1/2 is 1/2, and the absolute value of negative 1/2 is also 1/2. So your answer here would be, you can actually write it like this, plus or minus 1/2, okay? Or you can list them singly as 1/2 and negative 1/2, okay? Either way you want to list it, okay? And looking over at number 2, here it's saying absolute value is equal to -7. So think about what I've just said here, is just so far. Can you ever take the absolute value of something and get a negative value? You are not going to be able to do that, so this is no solution. Okay. All right, so in order to solve absolute value equations, there's a couple of steps. You'll isolate the absolute value bar to the equation. So if the absolute value bars are not already by themselves on one side, then you'll need to do the algebra to get it that way. Then you're going to separate your equation into 2 new equations using your absolute value property from above. At that point, you will drop the absolute value bars and then solve both equations, and those will be your solutions. I will demonstrate for you that now here in number 3. Solve this absolute value equation. So you can see here from the top that my absolute value is not all by itself. So I need to make a couple of steps to get it all by itself. So the first thing I would need to do is to take that 5 to the other side. So since it's +5, do the opposite. So I'll subtract 5. Let's make this a little smaller. So then it cancels out. So I have negative absolute value of 4x minus 3 equals -3. You have a negative sitting in front of here, so remember, think of that as like a -1. So I've got to get rid of that -1. Just divide by -1. Maybe do to one side, do to the other. That way it cancels out, and I'm left with the absolute value of 4x minus 3 equals a +3. I can now go through the steps of working this out because absolute value can equal a positive number. So this is what step 2 said. It said to set it up into 2 equations using your property from above. So what that means is that 4x minus 3 could equal a +3, and 4x minus 3 could equal a -3, because whatever's inside there, when you take the absolute value of it, it would get a +3. So you set it equal to plus or minus whatever this number is over here. So you set it equal to positive 3 and set it equal to negative 3. And at that point, you notice I dropped the absolute value bars. And then it's just a straightforward equation. So add 3 to both sides. 4x equals 6, divide by 4, x equals 3/2. So that's one answer. Come over here, add 3 to both sides. 4x equals 0, divide by 4, x equals 0. So those are your two solutions, 0 and 3/2. And you can write them in any order. I'll just box it in. It's not really an ordered pair. So 0 and 3/2 are your two solutions. So if you went back up now and went back to your original equation and plugged in 0, you would get positive 2. If you plug in 3/2, you're also going to get positive 2. Okay? I'm going to let you try example 4 because there's really not anything too new in example 4 to show you. Let's flip it on over then to the next page. You get, pause the video, you try number 3 and then or number 4, excuse me. Try number 4 and then come on over to, when you're done with that one and checked it on the solution key, come on over to the next page where we're looking at absolute value inequalities. Absolute value inequalities, like all the inequalities that we've looked at so far, your final answer is going to be a set of numbers written in interval notation. You are still breaking it up into two inequalities. You have to get it down to one individual inequality. This requires now a little bit of a thought, okay? If you start out with your absolute value being less than or equal to, it's going to break into two inequalities using and. If you start out with an absolute value being greater than or equal to, it's going to break into two inequalities using the word or. If you'll listen to my voice as I say this, I think this will help you. This is what helps me. Absolute value of x is less than, so less than and. Greater or. Okay, so when you start with less than or equal to, it becomes an and statement. So less than and whenever it comes to looking at your what your final solution will be, you're going to be looking to state where these inequalities overlap. Okay, so let me get a highlighter here. So highlighter. Less than. So it'll, if you have less than or equal to, it turns into an and statement, and you are looking for your solution is where those graphs overlap. And you'll notice how it drops the absolute value bars, and one inequality is exactly what you see in the beginning, and then your and one is you just flip the inequality sign and change the sign of the number. Okay. Now for your or, if you start with greater than or equal to, greater than or equal to, greater or, and so in this particular case, you're looking for everything that is being graphed, okay, from your two newly created inequalities. Greater, drop the absolute value bars. The first inequality is exactly how you see it, then it changes to or, and then you change the inequality sign and the sign of the number. Okay, we're going to need to do a few of these because these are definitely different. So the first ones I've got you started off here are a little bit more straightforward, shorter, and so you can kind of get the mechanics of it under your belt. So the first one, for all of these, you're solving the absolute value inequality, and we're going to write our final answer in interval notation. You'll solve it, graph it, answer in interval notation. Now the first one here, it's already got your absolute value bar less than or equal to 5, or just less than 5. So I'm going to write my two inequalities. So x is, remember the first inequality is exactly what you see there. So x is less than 5, less than, and then the other inequality, change the inequality sign, change the sign of the number. Okay, so less than, and so the first inequality is exactly what you see there, just drop the absolute value bars. Second inequality, change the inequality sign and the sign of the number. From there, if you had something to solve, you would. We don't at this point, so we graph it. So I've got my 0, I've got my positive 5 and my negative 5. At positive 5, I have a parenthesis, and I'm going to be shading to the left. So parenthesis at positive 5, and I am shading to the left. At -5, I have a parenthesis and it's pointing to the right, so I am shading to the right. Since it's and we're back up here, and I'm looking for where it's overlapping. This graph is overlapping where the red and blue lines are on top of one another, so between -5 and +5, parentheses on both. Okay, that's the difference here, because you might be saying, well, the whole number line is graphed. It is, but since this is an and statement, I'm only interested in where it overlaps. Okay, and so it's overlapping between -5 and +5. All right, let's scoot on over here to example 6. Again, first inequality, exactly how you see it there. It is greater than, so greater or, change the inequality sign and the sign of the number. These are already solved for x, so I can go to my number line. So I have 0, a +7, and a -7. At +7, I have a bracket, and it's pointing to the right, so I'm shading to the right. At -7, I also have a bracket, and it's pointing to the left, so I shade to the left. This is an or statement here. Or statements, you're telling, you need to now express to me everything that's being graphed on this number line. So I just need to use interval notation to account for everything that's being graphed. So from -infinity to -7, and then from 7 to infinity. That would be my final answer. All right, let's look at number 7. So in number 7, my absolute value bar is already isolated here. It is less than or equal to 14, so I can immediately start with writing my two inequalities. So I have 3x plus 5 less than or equal to 14, less than and 3x plus 5, change the inequality sign and the sign of the number. Now I go through the steps and I solve for x in both of these cases. So over here, I would subtract 5. 3x is less than or equal to, what's that, 9? Divide by 3. So x is less than or equal to +3. Subtract 5. Okay, 3x is greater than or equal to -19. Divide by 3. So x is greater than or equal to -19/3. Okay. I'm ready to graph on the number line. So 0, +3. You know, it's negative. It doesn't matter where it goes over here, just as long as you put it on the left-hand side. So -19/3. At 3, 3 is going to get a bracket. It's pointing to the right. So I'm shading to the right. I'm sorry, it's pointing to the left. I'm saying it wrong, but writing it correctly. It's pointing to the left, so I'm shading to the left. 19/3 will also get a bracket. And it is pointing to the right, so I'm going to shade to the right. Again, an and statement, I'm only interested in where they overlap, and hopefully you agree they're only overlapping here between the -19/3 and 3, bracket on both. That would be your final answer. Okay. Let's move on down here. I think number 8 and number 9 are some special cases. Okay, so I'm going to go ahead and work through all of these with you. You'll get some extra practice for yourself by doing my lab math homework. Okay, so here in number 8, you have it's already, absolute value bar is already isolated. So I have 7 minus x. Let me make this a bit smaller. 7 minus x is greater than or equal to -4. Greater or 7 minus x, change the inequality sign and the sign of the number. All right, so I go and start solving for x. So I subtract 7. -x greater than or equal to -11. Divide by -1. X is, I divided by negative, change my inequality sign, and then that would be a +11. So x is less than or equal to 11. Come over here, subtract 7. -x is less than or equal to -3. Divide by -1 again. Divided by negative, change that inequality sign, be +3. Now when I go to graph, I have 0, 3, and 11. At 11, I'm going to have a bracket, and this is pointing to the left, so I am shading to the left. At 3, I have a bracket as well, and it is pointing to the right, so I am shading to the right. This is an OR statement. And so an OR statement says, tell me everything that's being graphed. And so as you read this graph from left to right, every single number is being graphed because it goes to the left forever and it goes to the right forever. So your solution here would be negative infinity to positive infinity. Final answer. Okay, so just because the graph looks like an AND statement, you have to pay attention from the very beginning. This was great to or always tells me to look at my graph and state everything that's being graphed, and everything that's being graphed is the entire number line. All right, so down here in number 9, my absolute value bar is already isolated, so I'm going to start with breaking it up into my two inequalities. So 2x minus 4 is less than negative 5, less than, and 2x minus 4, change the inequality sign and the sign of the number. And now let's solve for x. Let's keep this. Okay, so now I would add 4 to both sides. 2x is less than negative 1. You're divided by a positive 2, so you do not need to change that inequality sign. You get negative 1/2. Add 4 over here. 2x is greater than 9. Divide by 2. So x is greater than 9/2. All right, so if I go to graph it on the number line, I've got 0, negative 1/2, positive 9/2. At the negative 1/2, I'm going to have a parenthesis, and it is pointing to the left, so I'm going to be shading to the left. At the 9/2, I have a parenthesis, and this is pointing to the right, so I am shading to the right. This is an AND statement. Remember, AND, you are looking for overlap. Does this graph overlap anywhere? Hopefully you would agree. It does not. So therefore, this is no solution. You can't say negative infinity to negative 1/2 and then 9/2 to infinity, because this is an AND statement and we're looking for where it overlaps, and it never overlaps. Okay. All right. Thanks a lot. Let me know if you need anything.